So this is probably a little bit easier section because there's really no assignment with this, but I still think it's an important thing to make sure you understand excuse me, what this is. So in Module 12, there is some content. Let me turn off the instructor view, go to student view. So what you have in here is a lot of content related to analog and digital. So I've actually tried to add some things and what I think are a little bit better, because I'm not crazy about some of this content. This is a lot of pop-ups and talking about the difference between analog and digital. So you can certainly read through that, make sure you understand that. But I added a couple things. Like this video talks about what binary is, because digital essentially is represented, digital signal can be represented in a binary way. Binary meaning one of two possibilities, because that's really what computers operate with. Computers operate with switches. So this video, I think, does a good job explaining that. Let me see if I can jump ahead here. Turn this down. You can watch this at your leisure, but they show how, because computers does everything with, this is a good shot right here. So imagine if each of these was a wire. And if the wire's off, it's a 0. If it's on, it's a 1. So the wire's either on or off. It's kind of like an electric light switch. It's either on or off. It's a 1 or 0. So a computer has to work that way because it's electrically powered. Now, they are doing research with another way to send computer signal, and that's quantum computing, but we're not quite ready for that yet. So right now we're still looking at things in binary. So I think this video explains why we use binary and does a good job explaining that. Now, how does binary work? You don't really need to be masters of binary, but you do need to understand how to go from decimal to binary and then back. So this is a Khan Academy video, which is a little on the lengthy side, but if you have the time to watch this, I think it's longer than it has to be. It's only 4 minutes, but I still think it's longer than it has to be. But this guy does a good job explaining how would I convert the number 13 to binary. So binary is just another way to represent value. We've learned from an early age, if we solve this number, we know that this means 13 of something. It's a value. It's a value that represents 13 of something. So binary, you can represent value with just ones and zeros. With the decimal system, we represent value with the symbol of 0, the symbol of 1, and 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 9, they're just symbols. They're symbols that represent value. And once we get to the tens place, we repeat those values. You say we have 1, 10, and 3 1s. Well, binary does the exact same thing, except the only values, the only shapes or symbols you have that represent value is a 0 or a 1. So he's trying to show you how you could convert from decimal to binary. Now you also need to know how to go back, how to go from binary to decimal. So this PDF sort of explains that. It does explain it, actually. I just think it's a little bit cryptic in the manner it explains it, but you should read through that or at least glance at it. And then this link talks about ASCII. ASCII is a way that the computer can represent all the characters on the keyboard to a numeric value, which that numeric value can be broken down into binary. I was looking for, I thought I added some other tools in here. So this is, I think, a good ASCII reference sheet. It's a little bit easier to understand. So in other words, like a capital A, when we type a capital A on the keyboard, it is represented as a 65, which this bits chart, this is really what is 65 in binary, and that's what it is. It's 0, 1, 0, 0, 0, 0, 0, 1, if I said that right. Like, what is a lowercase a? It's 97. What is 97 in binary? It's 0, 1, 1, 0, 0, 0, 0, 1. So all the standard characters on a keyboard actually relate to a number, which is then converted to binary. That's why ASCII is important. I was looking for another tool that I gave you guys. I'm going That's another type of ASCII chart. Here it is, the binary game. So I should probably move this forward. So you don't have to do this. I just thought it was neat because what you're trying to do with this is you're trying to say, okay, well, what is this number? I have 1, 8, and 1, 1. Oh, that's 9. So what is this number? I have 1, 8, 1, 4, and 1, 2. Oh, that's 14. How do I represent 16 in binary? I flip over this value. How do I represent 9? I flip over that guy, 1, 8, and 1, 1. 1, 1. How do I represent 4 in binary? Well, I don't need 128, don't need 64, don't need 32. I only need 4. What is this number in binary? 8, 4, that's 12, and 1 more is 13. Notice that all the odd numbers, they always end with this bit as a 1. Because I'm using that bit, well, I just did 13, so that should be easy. They asked me to do 13 again. I must really like 13. What number is this? We've already done it. That's 14. What is this number? 1, 8, 1, 2, and 1, 1. That's 11. So you're just trying to play a game, trying to convert from decimal and back forth to binary. So make sure you look at these activities and read through this. This is a neat little tool as well, just to hopefully help you understand binary. So this is kind of like old school. If you're driving down the road and you have an odometer on your car, keep track of miles. It works the same way, except it's keeping track of numbers in decimal, binary, hexadecimal, which is another base numbering system. Decimal's base 10, binary's base 2, hexadecimal's base 16, and then octal's base 8. We can have numbers in any kind of base. So I'm just gonna focus on, say, for example, here decimal binary right now. If I slow this down, you can see that the number 1 is the same in any number system. But if I continue, the number 2 is represented as 1, 0 in binary. And then the number 4 is 1, 0, 0. So what's 5? 5 is 1, 0, 1. What about 6? 6 is 1, 1, 0. And then you can continue on. Notice that all these other number systems, except for octal, once we get to 10, decimals using characters. Look at this. D for 13, E for 14, F for 15, and then it switches. So this is a neat little tool just to give you a sense of, if you let this go, you can see the binaries going wicked fast because it's only got 2 shapes to represent value. It's got a 0 and a 1. That's it. So it's going to be going at a much quicker pace. So all this materials is just material that you should have a basic understanding of in Module 5, or Module 11, excuse me. So just be aware that, I don't have that week turned on, but I will. So in Module 12, I'm sorry, I said 11, I meant 12. So in Module 12, it's not anything you have to do an assignment with yet, but you do need to have some basic understanding of what these things are.